Well, I could easily make 2,120 Rand per sheet of material. So these are money-making machines. So let's get to it and start making some money. Okay, so what are you going to do with your AM machine? You've bought a CNC industrial router. Now we need to make some things. So normally you would buy metal frames if you want to make picture frames, but we're going to make one on a machine because it's actually really easy and we can do it with loads of precision. I've drawn up some CAD files which you're going to be able to follow if you want to make frames similar to this. So let's go ahead and go get things set up. Alright, so what I'm doing now is I'm basically adjusting the machine to its position where I want to get things in. So we are going to be aligning the bit so we get a really even tool path. Because we want to optimize material, this is an offcut, but no offcut should ever go to waste, and that's exactly what we're going to be doing over here. Once I'm relatively happy, I'm going to go from jog mode into step mode. This allows me to move things really slowly. Let's go here, 0.1 millimeters. You can adjust this according to you, but I like to move in these increments. So now that I'm in step mode, I can move over exactly 0.1 millimeters to fine tune my exact positioning on our X and our Y axis. Once I'm happy with that, I can set my Z. Now I'm not going to set my Z on this particular axis, but what I'm going to do is I'm just going to lock this position in place. I'm going to come back into jog mode, and I'm going to find a position somewhere further up on the middle of the board. This is going to ensure that even if my board's not flat, my cutting is consistent across the entirety of the surface area. A lot of people make the mistake. They will set their Z axis from here, but they forget that the material is actually growing and expanding because it's a man-made object, and it is wood. Now I'm going to get really close. I'm going to hold shift to get back into step, and in this instance I'm going to step down 0.1 millimeters, and I'm turning the actual router itself until I can see that I'm just catching the material and I can feel it in my hands. There we go. Now I'm going to set my Z height, and now we have our coordinates set up. Now at this stage it doesn't matter where you've moved your router. I could bring it all the way through to the front because I want to stick on the dust collection system, and I'm basically ready to load my file. So let me go grab a flash. Alright, so I've got my flash drive. Let's get this guy up and running, and just like that we have our file loaded, and all we have to do is hit run. And while this machine is busy doing its cutting, I'm going to show you exactly how I've done the files for this project. Alright, so I've designed the basic frame within Fusion 360. You can do this in any software that your heart desires. I just like to do things in 3D modeling so I know where everything is. You can see it's quite a simple file. I've generated a whole 2 sketches which took about 20 minutes of my time in between doing other things. And right now I'm just making sure that everything is coming together, and so far so good. So let me jump into it and remove these tabs quickly. Here are our sides. I've created little pockets on this end and this end. This is going to help us square off. And this is something your CNC is really good at doing. I know a lot of people will try and do this on a saw. Not so easy. So we've got our 2 long pieces, and we've got our tops and our bottoms. And the way we're going to put this together is actually quite simple. Because we've done this all on the CNC, we know that we are going to be pretty square from the beginning without much fuss. Of course, we've got to get this side in, and what I've done is I've created a little pocket, and that is going to be the supporting structure for our frame. And all we have to do now is apply a little bit of glue and simply nail this together. Okay, so actually this is all a prop. I'm not really sweating. This took a whole minute and a half basically to get this whole thing together. And well, I didn't have to do all the work because that's why we buy CNCs. And there we go. We have a perfect 300 by 300 frame. All of our parts currently are on our workpiece and we are going to work off a full sheet of MDF. Now I'm using a spire, you can use any tool, and let's quickly go and break this down. So what I'm going to do is I'm going to come up here and I'm going to generate a full size sheet, which is 1830 by 2750. I already have my parts. This has got some tooling on. As a matter of fact, I'm going to close this and remove these tool paths. Everything is here. Now what I need to try and work out is how many we can actually put down on a sheet. Now this is hard for some people, but I'm going to show you a really easy way of doing this nesting. By selecting all of our material, I want to make sure that my end or my outer frame, which is going to be our sheet goods, is selected last. I'm going to come up here to nesting, and what I'm going to do is I'm going to decide how many parts we're going to get in. Oh, you know what? We can't get 54 in. We're going to have to try 53. Okay, 53, we don't have any secondary sheets, and we are very confident that we're still going to be able to use tabs because we have got our tool diameter listed within our Aspire. We know that we need about 12 millimeters clearance. As a matter of fact, this could be a little bit more, but we are getting in our frames to make 52 frames. So I'm going to click OK. Okay, so the question is, we know we can get 53 frames out on one sheet of material. Depending on where you're buying your material, if you do this as a business, you're possibly going to pay a little bit cheaper than what I did. I had to pay 780 bucks plus another 200 Rand for delivery. So we can basically call it 1,000 Rand. So let's go and do some simple maths over here. Pull out the calculator. So let's call it 1,000 Rand for our sheet goods plus delivery. Divide that by 53 frames. In actuality, that's going to cost us basically, call it 19 Rand a frame, which in all fairness, I haven't had to pay for anyone to come do the labor. It's pretty quick to get together. That's why I've done the push-ups, to make it look harder than what it was. But 19 Rand a frame, actually, it's not bad. So 19 Rand, not bad, but you know what, we still got to include things like nails and glue and so forth, so let's call it 20 Rand. And from my investigation, a frame like this could easily cost you 60 to 80 Rand, which means we can make anywhere between 40 to 60 Rand a frame, which, considering that I can make 53 frames, well, how much money is that? 40 bucks being on the low side. Let's have a look here. 40 times 53 frames, well, I could easily make 2,120 Rand per sheet of material. That's pretty good profit. And that's why these are the money machines.
AI may eventually take over, but what's for certain is that smart machines are already operating all over the world right now. So stay ahead with AM.CO.za. For 11 years, they've been the leader in CNC and printing machines like CNC routers, large format printers, vinyl cutters, laser cutters, plasma cutters, DTF printers, and many more. Visit AM.CO.za showrooms in Sunny Rock, Joburg, and Montague Gardens, Cape Town, or WhatsApp hi to 060 600 6000 for more. AM.CO.za. Achievement matters.